Good evening, sir.
Hello, can anybody hear me? Hello? Students? Oh, can anybody hear me?
Yes, sir.
Okay, I'm here. Good. Ngozi, you are there, right? Is it clear? Good. So without wasting much time, a lot of time has been wasted already. It was just a few minutes before we started, your class rep told you that he was asking for me making a proposal. But like I told you, that proposal will not actually work, considering the fact that I want real-time interaction during the class. So this is how we're going to have it. Hopefully we'll improve. Okay. So like this class is already being recorded, but I'm not going to release the video to you immediately because I don't also want to do something that would discourage other members of the class from participating. Because when some of you get to know that there will be video recording and they will have access to it, they may even choose to stay away from the class, which, in all honesty, I believe it will not help them. Okay. What I'm going to do is that I'm going to upload the recording on my YouTube page, and then I'm going to share the link with you so that you can go there and access it at will. Okay. So if you are set, I'm set. I want to continue from where I stopped yesterday. But before then, let me ask, is there any question arising from what we discussed last class, rather? Any question? Okay, I will assume there are no questions. Okay, so I'm just going to give a quick recap. The first class we had. I want to believe you can all see my screen. Can you all see my screen?
Yes, I can see your screen.
Okay, good. So again, we started from an introduction to what statistics is all about. And I explained the relevance of statistics to veterinary education. Okay, we started by looking at some basic terms or terminologies in statistics. And the first of them is the word variable. Okay, I told you that this is a word you are going to be coming across from time to time as you study statistics. Because essentially, statistics is all about discussing variables. You know, I said statistics is essentially the study of a population. You want to study the population, study the characteristic of the population, the various attributes of the population. These attributes are what we refer to as variables. Okay? And because for every element of the population, for each entity of the population, they are bound to change. Okay? That is why we give them the name variable. It varies from one element or one object or one entity of the population to the other. I hope that is clear. So we look at the fact that research is actually looking at relationship between variables. I'll explain that. So I told you what the population itself is. The entire group of individuals in focus is what we refer to as population. And I told you in population study, because more often, population is usually a large concept. And because we don't have enough resources, we don't have all the time, we don't have even the feasibility of meeting every element in the population is not there. And sometimes you have dynamic population. Like think of Nigeria population now. You know, currently we have this Japa syndrome going on. People are traveling out, some are coming in, some are moving out. So we have an actively mobile population. So it's even difficult for you to track anybody down. So essentially in population studies, more often than not, where we realize that we cannot reach every element of the population, it becomes necessary to take sample from that population. So in science, biological science, any area of study, essentially we work with sample. We take sample. We just take a sample. It is presumed that when we take a sample from a population, if the manner of taking the sample and the amount of sample we took is a good representation of the population, we can make finding about that sample and we can apply it to that population. That is essentially what we do in research. Okay? So we say sample. Sample is just a selected portion. It's a representative of the population, like I've said. And the idea is to obtain a result from that sample that we can extend, we can use to answer questions about the entire population. And I've just shown you the schematic diagram showing how population, example from population, study, and then you generalize your findings to the entire population. I told you there are two types of population time around. Discrete variable, continuous variable. Discrete variables are integers. They are indivisible value or category of variables. I only have 5 people.
Sir, we can't hear you loud and clear anymore.
So please recap the sample portion. I didn't get you.
Sorry, sir, we can't hear you.
Hello?
Hello, sir.
Can you hear me?
We can hear you now.
Those that can hear me should speak up now. Let's know if the problem is with those that cannot hear. Don't just keep quiet. If you can hear me very well, indicate. Let me know. And if it's a
So we can hear you.
We can hear you now, sir.
Okay, good.
I hear you, sir.
Okay, great. So, somebody was saying I should recap about sample part. I said sample is just a selected portion of the population. You want to study the entire people in your village. You can't touch every member of your village people. Then you decide to pick your family member and study them. And whatever the findings you had about your family members, you generalize it to all your village people. That's what sample is. I'm telling you, this is not the first time you are hearing sample. You want to study the health of a cow. You go to abattoir, you pick a sample of that poo-poo. Just take a little of this poo-poo or take a little. You want to study the health of a human being. You're not going to harvest the whole blood of the human being now, or maybe cut the neck or just puncture the baby and remove all the blood. You just need a sample of the blood. You go to hospital, you are sick. They want to know if you have malaria parasites or fever. What would they do? They will just take a little of your blood sample. You have heard the word sample again and again. So it's not different from what you have heard before. Hello? Ngozi?
Hello, sir. We can hear you.
Ngozi, is it clear?
Yes, sir.
They'll take a sample of your blood and then they'll screen the blood. And if they have parasites inside that sample of blood they have taken, depending on the situation surrounding how it was taken or where it was taken, then they should be able to tell you have malaria fever. So that's what sample is all about. So, and I've said we have we've got discrete variable, we have continuous variable. Discrete variables are indivisible categories. These are kind of variables that you cannot divide them. They must come in absolute value, absolute figure. For instance, if I'm to ask, how many liter of piglet or pigs or whatever, or how many puppy, you can say 5, you can say 6. How many of you are in the class? You can say 10, 15. But you cannot have 4.5. You cannot have 4.1. You cannot have 7.2. So when you have a type of variable that comes in discrete value, we refer to such variables as discrete variables. Your class size is a discrete number. But when you talk about weight, the weight of the body, you talk about height. Somebody can be 5.2, somebody can be 7.2, somebody can be 6.5. Any value, any measurement that carries decimal point are described as continuous variable. Does that make sense? Is that clear? Okay. So that's this continuous and discrete variable now. So the next thing I talked about is measuring variable. That's usually we measure variable on different scales. Okay? There are different scales of measuring variable. Of course, the essence of looking at variable is to compare them. That's what the researcher wants to achieve. That's what the statistician wants to achieve. Okay? He wants to look at those variables, compare them. But there's a process of measuring this variable that he must establish to know how to categorize the different variables. Okay? We are looking at the category based on absoluteness of the variable, discrete variable, continuous variable. But this time around, we are looking at how variables are measured at the same time. And I told you there are 4 scales of measurement of variable. We have the nominal scale, we have the ordinal scale, we have the interval, and we have the ratio scale. The nominal scales are those ones that are not ordered. Okay? They are not ordered. Usually, nominal scale measurement only give us distinction. It tells us difference if two variables are on the same or on different scale. Okay? For instance, somebody is from Anambra, another is from Enugu State. There's no indication that somebody from Anambra is greater than somebody from Enugu State. The state is just their identity. You just give an identity. Number one, you can either know if the people are from the same state or from different states. Those are kind of variable we describe as nominal variable. So your state of origin is a variable itself. It means it is a factor that varies among you. If I told you now in your class that, okay, please list your various states of origins for your class. Some people will indicate Igbo, some will say Enugu, some will even tell you Lagos, some will say Anambra, some will say Kogi. So all these information, pieces of information are only telling us that, okay, some belong to the same, some are. So that is what we call nominalization. While ordinal is something that is ordered, okay? Something in rank, something based on ranking. For instance, if I ask you, what is the level of education of people in your village? You can categorize them. Some are primary school holders, some didn't even go to school at all. Some are secondary school leavers, some are university graduates, some they are their masters, some are PhD, some are the professorial level. That is order. That is ordering. You have it order. You can ask for somebody that's what's the grade of that person. You can somebody is poor, somebody is average, somebody is fair, somebody is very good, somebody is excellent. That is order. That's ordering. So when you have variable in that format, we say they are measured in ordinal scale. And also we have interval scale. Interval scale follow the same level with ordinal scale. But in this case, the difference between each stage, each rank is constant, is of equal size. We say it is interval scale. While ratio scale, the zero is not arbitrarily fixed. Unlike the interval scale. I'm still going to explain that with example. Let's just move on. Correlational study, of course, we say we want to look at the relationship between two studies. And that is most of the commonest type of study that we conduct in social sciences and all that. Okay, sorry, let me admit a few more people that are knocking on the door. Okay, so that's what we discussed in the last class. You can see this graph. This graph is still giving us a picture of what we are talking about, okay? Or that table rather, and the graph below it. And also, I talked about experimental study. I've explained briefly what it means. Experimental study is when you make inputs. Okay, if I give this person poison, how soon will he die? That you are making input, you are intervention. Okay, and sometimes we come up with variable in that kind of research study, and we want to know the relationship between those variables. You want to gather your rats, measure different types of extracts that will help them maybe aid their fertility, aid their egg laying, or whatever. That's experimental study. Okay. So, and in experimental study, we also talk of independent variable, we talk of dependent variable. Hello, are you still with me? If you are still listening to me, can I hear?
Yes, sir. We are with you. It's just that some of my classmates are waiting to be admitted into the class, sir.
And then I'm admitting them as I'm talking to you. They'll be joining. They are late comers, so they will also stay class outside or at class.
Where is the class now talking? Why can't I hear anything?
So I can't hear anything. Shiva, can you hear anything?
No, I can't hear anything too.
Hello, can you hear me now?
Yes, sir.
Yes, sir.
Okay, you can all hear me better now. Can you see
Yes, sir.
my screen? Can you see my screen?
Yes, I can see your screen. PowerPoint presentation. That's the.
Yes, you can see the PowerPoint presentation.
Yes, sir.
Okay, so what can you see on the screen? What can you see on the screen before I continue? What can you see on the screen?
Where you just think the page. That is step 1 experiment.
Okay, good. So it means I'm loud and clear. So I continue.
Then step 1 experiment.
Okay, don't worry. I understand your network is
teaching methods.
your network is a little bit bad from that end. Okay, so I continue now. Like I said, you have under step 2, you can see sample A and sample B. So in this case, we're just presenting this in table form, also in graph. That is
I just feel somehow that I have limits. Do you understand? Yes.
Those are descriptive statistics, okay? Why step 3, you see the data is now being interpreted. There's a form of interpretation going on here. There's a form of comparison going on here. Say that is inferential statistics, okay? So, Deborah, please, if somebody is close to Deborah there.
Harrison, what's going on?
You need to ask me. Now we can't hear anything.
So your mic is mute too.
can you hear me now?
Yes.
Here. Okay, good. Good. So where did you stop? Where did you miss out?
Well, let's start from this first. This new file you just opened.
So, and again, I told you that
So we can't hear.
Please do.
Do you hear me?
Please, Peru, can you?
Do it. They'll find it.
Peru, can you off your mic?
Chinwe, can you hear anything?
No.
you hear me now? Hello?
Yes, sir.
Yes.
Yes, sir.
Let's just manage. So please, who is this person to? Let the person. Okay. So, like I said, we can view statistical methods from this perspective. Okay. We can talk about descriptive equation. Okay. And again, we look at this slide that is on display. You can appreciate that statistics describe a numeric set of data by its center, by its variability, by shape. Okay? When you say description by center, you are talking about measure of central tendency. And what are the measures of central tendency? Who can help us? Quickly. What are the measures of central tendency?
Me more than
Yes, mean, mode, and median. Those are the measures of center. How about variability? What are the measures of variability? Oh, anybody? What are the measures of variability? What are the measures of variability? Hello? What are the measures of variability? Hello? What are the measures of variability? Can you hear me?
And you said there's nominal, ordinal, and
Those are not measures of variability. Things for measuring variables. Measures of variability I'm talking about include variance, standard deviation, and the like. Those are what we call measures of variability. Okay? So, but it's different from the scale for measuring variables. Please don't mix them together. I'm saying it now, don't mix them up. So, and we look at shape. We talk about cortices. Cortices, those are, we're still going to meet it at the end as we continue. Now, sometimes you are dealing with categorical set of variables. When you deal with categorical set of data or variables, the usual way to describe them is to use frequency table, percentage, or proportion of each category. Okay? I believe they are listening to me.
yes, sir, yeah.
Okay, great. So, variables, again, look at it as any characteristic of an individual or entity. Okay? And it can take different value for different individuals. And these variables can be categorical or quantitative. When we say categorical variables, okay, these are variables that put people into different classes, into different groups. We say categorical. Okay? Categorical. For instance, you can have a male and a female. That's gender. So the gender can come in form of category. Okay? But when you talk of quantitative variables often come in form of this. It does not necessarily put people in categories, but it gives specific information about each individual. Like when you say your age or your weight, those are described as quantitative variables. You can quantify them. Okay? So, that's for that. Now, again, I explain types of variables or the scale from which you measure variables. I talked about nominal. And here you have a few more examples that should further explain to you what we are talking about. Okay? Nominal includes gender. Male, female. Male is not necessarily bigger than female. Neither is female necessarily bigger than male. They are just mark of identity. While when you come to ordinal, you have them in rank. Mild, moderate, severe. Okay? And you could be in terms of comparing equality, greater than, less than. Okay? Those are ordinal. So we describe them as type of variable We also describe it as scale of measuring variables. Please don't get confused. We are still saying the same thing. While the interval scale, in this case, variables that are order, of course, but in addition to being order, there is a meaningful value in between the scale. Okay? Meaningful distance in between. For instance, if you look at the date on the calendar, distance between one date and the next date will be 24 hours. Okay? And of course, you can add, you can subtract, but you cannot perform multiplication and division with this kind of interval variable. Okay? Why for ratio scale, a little bit different. Because it has all the property of interval plus absolute or non-arbitrary zero point. Okay? Okay, so again, this is talking about shape that I just mentioned the other time. Okay? When you plot a curve, you look at the shape of the curve itself. This is the frequency distribution I mentioned the other time. Cumulative frequency, data presentation. Okay? Now, usually when you present data, there are two ways you can present statistical data. You can have the graphical, you can have the numerical. I mean by graphical presentation already. Okay? And depending on the nature of the variables you are looking at, if they are categorical variables, you must of course present them either using bar charts or pie charts. But if they are numeric variable or what you call quantitative variable, you present them as histogram, stem and leaf, and burst plots. Okay? So here we have an example of the bar charts. You can have a table of data this form of the bar chart. Okay? You can also have pie charts. These are things you have done in your elementary, what's it called? Elementary mathematics. In CAP, all what we're talking about here. Burst plots. Okay? Now, there's what you call skewness. Skewness in data set, in a data set. Can you still hear me? Am I still communicating?
Yes, yes, sir.
Okay, good. There's what you call skewness in data sets. Usually when you gather information from a sample or group of people, maybe about a specific variable, there are times you are going to have what we call outliers. 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 Let me show you. There's a place. Okay. See the word here. This word, outliers. Okay. Now, what do we mean by outliers? For instance, you want to take the documentation of the age of your class member. That's DDM4, right? You want to record your varying ages, various ages. Let's assume there is somebody in your class that is 60-year-old, or someone in your class that is 14-year-old. Ordinarily, you will not expect such person to be in that class. Am I right? But
you are right, sir.
Yes, but maybe for one reason or the other, somebody just felt, I want to go back to school, and he went to vet school at the age of 40. By the time he got to 50 years, he was already 45. By the time we gathered the age of your class, that person's age would be what is called outlier, lying outside, outlier. Are you with me? Or we got somebody that is 14 years old. By the time they gave the person the admission, maybe maybe somehow they admitted him too young into the class. And why the rest of you are averaging 25 years old? This person is 16 years old. That person is also considered as an outlier. Now, if I'm to plot the various ages of your class on a graph, I'm going to have a shape called a dumbbell shape. Dumbbell, look at this shape you are seeing on your screen. I want you to focus on the orange color, or you call this one orange now. Anyway, just look at your screen. You see the one that looks like orange color. Usually, if I'm to plot the ages of your class on a graph, I'm going to end up with a curve like this. I'm going to end up with a curve like this. We refer to this curve as Gaussian curve. We call it Gaussian curve. So we're going to talk about it again. We call it normal distribution curve. We call it a dumbbell shape curve. Give it different names. Okay? Now, one thing you are going to notice is that because this person that is 45 years old is an outlier, the person's age is going to drag this curve to the point that instead of the curve to stand as erect as the one you are seeing on this, it will flatten out because somebody with an unusual age in your class. So we refer to such value or observation in the data set as outliers. We call them outliers. This outlier can be towards the right-hand side. It may also be towards the left-hand side. For someone that is 45 years old, the person's age will be towards the right-hand side. For someone that is 16-year-old, his age will be towards the right-hand side. The age of the person was the right-hand side. This is what I mean. The age of the person will be here for 16-year-old. For somebody with 45-year-old will be here. Or maybe let me use a marker, a pen marker to show you what I'm saying. Okay? Somebody with 45 years old will be here. 45. I believe you are seeing what I'm writing on the screen. Somebody with
Yes, sir.
Somebody with 16 will be here. Okay? So we refer to it as what? Outlier. These are outliers. Okay? And what they do when you have outlier in the data set is that they will flatten the curve. This is our curve. I've given this curve several names. Okay? Number one, I call it Gaussian curve. Look at your screen. I'm trying to spell Gaussian. 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 So you can write it down. It's called Gaussian curve. Okay? And sometimes you can call it normal distribution curve. Normal. From the word normal. Normal distribution curve. From the word distribution. To distribute. Okay? Normal distribution curve. And sometimes you can refer to it as a dumbbell shape. Dumbbell. Dum. From the word dum. Dumbbell. You have it. I believe you are seeing what I'm writing. Is the class rep here?
Yes, sir.
Okay, good. So please be my eye in case missing out something there. So that's what we are talking about. So again, we said these values are outliers. Outliers. Out. From the word out. Okay? Outlier. Something lying outside. Outlier. Outlier. Okay? These two values. Okay? Because they are unusual. When you plot the data set for your class, somebody with this age, you have somebody with this age will be found outside these two. Okay? Is it clear?
Yes, sir.
So you can have
We can't hear you again.
How about now?
Yes, we can hear you now.
So if you look at the screen or the slides that is being displayed, now you see two different data sets. Number one is, let me call it data set A. You see it here. The second one is data set B. Okay. Now, if you look at these two data sets, they look similar. One is 30, 50, 70. That's what we mean by data sets. When you gather information like call it data sets. Call it data sets. Okay. Now, if you look at the two data sets, okay, can somebody tell us the mean of both data sets? What is the mean of the two data sets? If you are listening to me, can somebody help me with the mean? Oh, you are not hearing me again?
Can hear you, sir. That is 50, sir.
Yes, the mean of these two
that is 50 for A.
Yes, 50 for A.
The second one is also 50.
Yes.
The second one should be 52.
Okay. Now, what we are trying to establish here is that, you know, in measure of central tendency, usually we have three measures. Basically, we have three measures of central tendency. Okay? Number one is the mean. You see it on the screen. I'm writing on the screen now. Number two is the median. Okay? Median. While number three is the mode. Mode. I know you must have been taught this in your elementary, what is it called now? Google Miracle, please, boot yourself. You are disturbing. So you must have been taught this in your elementary mathematics, but you may not really appreciate what we mean or what was meant by measure of central tendency.
I'm actually listening to you. Forget. Seriously,
Miracle, can you off your mic, please?
If I remove her, she will not be able to log in again. So, measure of central tendency. The idea is that if we have a data set, we can use a value to represent our data set. For instance, let me give you another data set. Let's assume we have 15, we have 16, we have another 16. Let's say these are the ages of the newly admitted students in first year vet medicine. Okay? 19. Like this. Okay? Now, if somebody wants to know what is the average age of students in first year, how will you determine that? All you need to do is to go and find out the ages of the students in first year, just the same way I'm written this on your screen. When they give me their ages, what I will do is to find the average. Let's say the average of this, or what I'm written here now. Let's say the average is 17.5. Okay? This is the mean, right? Now, what is the essence of having a mean? Is to be able to represent a data set with a value. That is why we talk about measure of central tendency. The idea is that we want to be able to represent a data set with a value. That's what we describe as point representation. What to represent? For instance, now, maybe you are a sales girl or a sales boy in a particular shop. And there's another sales boy that the owner of the shop employed to be selling the same products at another location. And the owner wants to know who is doing better, who is working hard among the two of you. The owner now recorded different sales each of you has made over a period of 2 weeks. And you now find the average of your daily sales for 2 weeks. Let's say one of you had a sales of 20. Second person has a sales of 21. You see, that 20 is used to represent your average sales on daily basis for 2 weeks. So with this value now, the main that the owner is able to compute from, he can tell who is performing better among the two of you, because he has represented your daily sales for a period of 2 weeks with a value which is the average. That's your average sales. The same way, we can use 17.5 to represent the first year class and say, okay, those in first year class, they are averaging 17.5. So that is what we mean by measure of central tendency. But beyond using mean, you can as well use, you can also use mode. Use mode, you can use median aside using mean. But the fact remains that what will determine the best measure of central tendency, that is, which of these three best explain or summarize a data set, will depend on the data set itself. It will depend on the data set itself. Number one, how skewed the data set. How aggregated, closely aggregated is the data set. Now let's come back to this example on the screen. We have both agreed that the mean of these two data sets seen on your screen, they're what? 50. But if you look at it clearly, you will realize that that 50 better represents the second data set than the first data set. You agree with me?
Yes, sir.
Because if you look at these data sets, the first data set, you will see the difference between 30 and 50 is very wide. And the difference between 50 and 70 is also very wide. It's twice the distance between 40 here, 40 here, the 40 here, and the 50 here. The difference between this one is 10. The difference between this one is 10. So the summary of what I'm saying is that our mean is best used as point representation of any data set that is not what? Skewed. A data set that is normally distributed, that is not skewed, that is the best situation to use our mean. Okay? Compare with when the data set is skewed, that is far apart. So that's why I said, in the case of B, 50 as our mean is the best measure of central tendency in this case than in this case, because our data set here is skewed for sample A, for data set A. Let's continue. We'll get it along, okay? So we said measure of central tendency, we have our mean, we have our median, we have our mode. And of course, in advanced level, we also talk of geometric mean. But basically, we are looking at just three. Okay? We have more than 3 measures of central tendency, but more often than not, we look at 3. Now, let's look at this example on the screen. You see, the mean of this particular data set is what? Is 30. That's how to calculate our mean. We just add the observation together and we subtract it by the number of observations, and then we get our mean. For our median, how do we get our median? I don't believe I need to be explaining this again. We arrange the observation in increasing order or decreasing order, and the one at the middle will be your median. In a situation whereby you have 2 values at the middle, like this, having 5 and 6 at the middle, you add the 5 and 6, you divide by 2 to get your median. Why the mode is usually the value with the highest frequency. Okay? So, but you know there are times we have a situation whereby none of the observation is repeated. We say the mode in that case is undefined. See it there. This is there for you to read. When you have a data set with unrepeated value, unrepeated observation, say it's undefined. Any questions?
Yes, sir. Please, I don't understand or get when to use me. You explained something on when you should make use of me and when to make use of me, and I did not get the explanation.
Hello, I can't hear anything.
Population are tightly packed. Your mean is the best measure of central tendency. But when your observation are loosely packed, separate, I just use an illustration just now. Where you had 40, 50, and 60. And then you have another one, 30. You have 50. You have 70. And I told you in these 2 cases, these 2 data sets, the mean is both equal to 50. But the difference is that this 50 will better represent the first one here than this second one, because this one is tight, they are tightly packed. What is the difference between 40 and 50? 10. What is the difference between 50 and 60? 10. But what is the difference between 30 and 50? 20. So they are separate, apart. They are separate, apart. How that is clear?
Yes, and that means for the 2 data sets, the mean for the first one is more appreciated than for the second value that has 30.
Exactly. The mean is a better representative. For instance, in your family, you are the last born. But you have a big brother, an older brother. He's the firstborn in your family. If your father wants to send somebody to go and represent the family, he won't choose you as the last born, because the older boy, he knows a lot about the family than you know. Does that make sense? Is that clear?
It's not.
Yes. Yes. Yes, sir.
Somebody is still going.
Is it clear?
So I didn't get it though. I didn't get it.
I didn't get it, so it's not clear.
Don't worry. Sometimes you may not be able to get it at once like that in class. There are times that your colleague will explain to you better. So after the class, just meet one of your colleagues and let the person explain. So,
Sir, sometimes as though like your voice moves away from the mic, your voice will come close at the same time to still go back again.
how's my voice now? Is it closer or far away? How's my voice now? Hello?
Hi.
It's okay now.
It's not easy. All right. Let's continue.
Hello, sir.
Yes. Is it clear now?
I can't hear anything. No.
Can you hear me?
Yes, sir.
Okay.
Sir,
So,
your
Okay.
voice.
hello? Somebody is talking?
Sir, we can hear you.
Okay. So, look at the screen again, the slide. See, median is less sensitive to outliers. That's to further buttress or to explain again what I was saying the other time. The median is less sensitive to outliers. When you have extreme values, the medians remain at the median. Okay? But the mean is usually affected by extreme value. So when you have a very skewed distribution, the median, look at that second statement. Our median, this second statement here, our median is the best measure of central tendency than the mean. Now look at the example given on the screen. The daily milk output in a farm, for example, we have 20, we have 20, we have 30, we have 40, and another day we have 990. Okay, these are the values of the daily milk sales. If you want to know the output of that particular farm, and you now decide to find the average, you are going to end up getting 270 as the daily milk output. And that means that average, if you use it to judge the farm, you will misjudge the farm. Are you with me?
It's making sense, sir.
A particular farm, they're making daily milk output on that farm. First day, they got 20 kg of gallon. Another second day, they got 30 kg. There was a day they got 40 kg. All of a sudden, they just reported 990 kg on that farm. Now, if you now want to judge what is the average daily milk output on the farm for the past 4 days, if you took the average and you got 270, you will misunderstand. In fact, the information you are going to put out about the ability of the farm will be misleading. You get what we are trying to say now?
Yes, sir.
But instead of doing that, when you notice, you see, this is what you call a skewed data set. Skewed in the sense that you have a figure that is very far away from the rest of the data set. For the rest of the observation, rather. You have a figure very far away. It's just like,
I have a question, sir.
okay. That's your question.
Does that mean that probably there was an error in data collection?
There can be error, course, but it may not even be an issue of error. Like the case of the age of somebody I use in your class. Somebody is just 45 years old in your class. Is the presence of that class is the presence of that person in your class an error? Technically, it's an error, but it's not necessarily an error. You get what I'm saying?
Yeah. Yes. Just like Chinwe is 40 years now. Not really an error, but
Who is 40 years?
our class rep.
Okay, he's 40 years old. Oh,
Yes, by
I see.
this month.
Okay, that's nice. That's nice. Okay, so your class rep is a typical example of an outlier. So when next I ask for the outlier of your class, then point out your class rep. So, but like I was explaining, whenever you have a skewed data set like this, the main is not the best representative of that class, of that data set. Rather, you think of the median or the median. And how do you calculate the median? Of course, you want to arrange the data set and pick the middle value or the middle values and divide by 2 whenever you are dealing with even number data sets. So that is how we do it. So you can appreciate that taking a mean of 270 is unrealistic. Okay? So realistic is misleading. It's misleading. That is why we said whenever you have a skewed data set, which is usually caused by an extreme value, what you should do is what? Come to the media. This question will come out in the exam. Okay? Now, what
So you say which question will come out in our exam? So you say which question will come out in the exam?
The exam is more important than learning.
Chinwe, now what's this now?
It's important now. What is this?
Doc, your mouth is away from the mic. We cannot hear you.
Allow the old man now.
Ah. Hello. Jesus, what's going on? The slides are just skipping as though we are learning it. Hello, sir. We cannot hear you. You are still teaching. None of us hear you.
You hear me now?
Now
Okay.
we started hearing you.
So,
Just now. All those
so
slides have passed. We don't hear you.
you don't need to bother yourself about this slide because you have been taught in your own level. So just dust your notes.
Sir, please, we're not talking about it.
You said what? So we talk about skewness, we talk about kurtosis. I've explained all that. The skewness measure the asymmetry of our data set. Okay? While the kurtosis measure the thickness. If I go back, we have, look at this curve. Okay? The skewness talk about the how is it asymmetrical? Our curve, is it asymmetrical? So you talk of skewness here. Why here? Talk of kurtosis. Okay. So these are attributes of our Gaussian curve. Okay. So I think that is a convenient place to stop. There's nothing much again to talk about. From tomorrow, we start talking about, from the next class, we will now move to another topic. Is there any question? Any question, please?
Sir, I don't understand this QS and kurtosis.
Any other question?
Sir, yes, my question is, when you were explaining the outlier, that is in terms of that 990 in the farm, I didn't really get what you said we should do with the outlier. That's in terms of when we want to calculate the mean. Does it mean we should remove the outlier and then calculate our mean? Because I overheard you saying that if we calculate the mean that way, as in we kind of, I don't know how you put it, is it kind of overrating the farm? Because at the long run we got 270, which is not really tallying with, how will I put it, like the small values that were there before. So does it mean we are to remove the outlier and then calculate our mean, something like that? That's my question.
Any other question? Any other question? Any other question?
I don't think, but maybe at the end of the lecture, you can just summarize the whole lecture for people that came late.
No, I won't summarize for this activity.
Okay, sir. I wanted to ask how soon we can get the link to the YouTube channel, because I don't know if it was my network. I have a whole lot of half knowledge today.
I'll let you know. Okay. Somebody was asking what I meant by using the name or the media as representative. I'm not saying you should remove outlier. I'm just saying wherever you see outlier, the median is the best measure.
So please, you were saying something about exam question. You wanted to give us example.